minus 1 dx. So with this problem, the denominator is simple, just one linear factor of x minus 1. But this fraction is not proper, okay? Because the numerator is of degree 4. Denominator is of degree 1. So we have to do long division. And by the way, I bet you guys heard something, or we have learned something called the synthetic division. Synthetic division can only apply if the denominator is of the simple term of x plus or minus a constant. So in here we can use synthetic division. Synthetic division. Okay? If you don't remember, that's okay. Just you don't know, that's okay. Just do long division in the normal way. I can do synthetic division in here. 1 x to the 4 means what? 1 x to the 4, 0, 0, 0, and 0. This means what? 1 x to the 4 plus 0 x cubed plus 0 x squared plus 0 x plus 0. Okay? Now bring it down. Bring the 1 down. 1 times 1 is 1. Got a 1 down. 1 times 1 is 1. 1 plus 0 is 1. 1 here. 1 down. And then 1 times 1 is 1. But the 1 down. This is the remainder. So if you do this fraction, it's going to be equal to, so x to the 4 over x minus 1 is equal to x cubed plus x squared plus x plus 1 over x minus 1. Okay? And if you've been working with polynomial long enough, and this is how I usually take care of the problem. I'll see it x to the 4, I can write x to the 4 minus 1, and then plus 1 over x minus 1. And I know this is factorable. X to the 4 minus 1 is x minus 1 times x cubed plus x squared plus x plus 1. Okay? So this is what? X minus 1 times x cubed plus x squared plus x plus 1 over x minus 1 and plus 1 over x minus 1. And I still have the same answer. That's how I really see in the problem when I first write it down right away. But since I have to explain it to you, and I don't think all the students, I guess, I'm not sure, but I guess not all students know the factorization right here. This is what you learn in pre-cal as well. So if you don't see it, that's fine. Do the regular way to do long division or synthetic division, you have the same answer. Okay. So anyway, this integral will be the same as the integral of x cubed plus x squared plus x plus 1 over x minus 1 dx. Okay? The first part right here is the quotient. Actually, just a polynomial. So you integrate this. It shouldn't be too hard. It's 1 over 4 x to the 4, 1/3 x cubed, 1/2 x squared plus x, and the antiderivative of the integral of this is going to be ln of x minus 1 and then plus c. See, you have the answer. Okay, we have enough for easy problem. Now let's get to something that is a little bit harder. I'll just randomly choose one. I don't know. It's a lot of exercises in here. Oh, I see this. X squared plus x plus 1. Yeah. It's long, so I have to make sure I copy it right. So integral, oh boy, big one, huh? X squared plus x plus 1, x squared plus x plus 1 over x squared plus 1 squared, x squared plus 1 squared dx. You see this problem, we have to do the integration of a rational function. And this is a proper fraction because the top, the numerator is a polynomial of degree 2. The denominator is a polynomial of degree 4, x squared squared, so x to the 4th. Alright, so it's proper. And to deal with this problem, the first thing is to decompose a fraction out. Alright, so you try to decompose it. X squared plus x plus 1 over x squared plus 1 squared. I see that in the bottom I have only one quadratic factor is x squared plus 1 with multiplicity 2. So I know that I'm going to have x squared plus 1, alright, and list all the possible multiplicity. Multiplicity 1 could be x squared plus 1 with multiplicity 2. And since this is quadratic, I may have a linear on top, so I call what? Ax plus b. And this is going to be cx plus d. I have to solve a, b, c, d to find out the numerator of the partial fraction. Alright? And the common denominator is x squared plus 1 squared, so I need to multiply the first fraction back by x squared plus 1. Right? So x squared plus x plus 1 going to be equal to ax plus b times x squared plus 1 plus cx plus d. And then you guys have to solve for a, b, c, d in here. Alright? We solve for this. We're going to have a system linear equation of 4 variables, I think. And we have to solve, right? Let's see if we have any shorter way. The answer should be a yes. So let me show you the shortcut that I see in here. I can regroup it. Well, this is a formal way, okay? But it's not all the time the formal way is going to be the quickest way, even though that you want to solve it. Plug in some value for x, you have going to be 4 equations with 4 numbers you solve. It'll take a lot of time. So let me cheat a little. I'm going to rewrite the fraction right here. X squared plus x plus 1 over x squared plus 1 squared. Just because of the nature of this particular example, they give you very nice numbers. That's why you can go around with it. But if you change the number, then this will be the formal way to do it. I can think of it this way. X squared plus 1 and then plus x over x squared plus 1 squared. I'm just rearranging the two terms. Okay, 1 and x. And this is what? X squared plus 1 over x squared plus 1 squared plus x over x squared plus 1 squared. You see what I've done? I just break it out into a fraction. X squared plus 1 over this and then x over this. Okay? And this one is the first fraction. We have a common factor between numerator and denominator, so it's 1 over x squared plus 1. And the second one is going to be x over x squared plus 1 squared. So I got the answer quickly. So if you do this way, then what? A going to be 0, B going to be 1, C going to be 1, and D will be 0. Alright? It's going to take a lot of time. So this will be a lot quicker. But you might change a little and say x squared plus 2x plus 3 over this. Then we may have to go over the whole thing right here. Or maybe not. No. Alright, so we're done with decomposing the fraction. Alright, observation helps. This is integral of 1 over x squared plus 1 dx plus the integral of x over x squared plus 1 squared dx. And this one, we have formula already. This is tangent inverse of x. Alright, and this one, all you have to do is to use up. Because you got an x in here, that's the key. That's a great helper. You let u equal to x squared plus 1, du is 2x dx. So this integral will equal to, on the top is x dx, right? So 1/2 du over u squared. This is 1/2 integral of u to the negative 2 du, and I'm glad that you guys can take care of this one easily. Okay? Ooh. So we don't really have to go through all of those formal steps that we learned in pre-calc. But anyway, we still have to decompose the fraction. Alright, but I show you a shortcut. I just erase it to decompose the big fraction. Okay? And how did I see it? Just practice. Another one. Just right next to it then. This is long, so let me have to copy one by one carefully. Integral, and I see a big fraction. The top is x cubed minus 2x squared plus 2x minus 5. And the bottom is x to the 4th plus 4x squared plus 3 dx. All right, let me double check, make sure that I copy all the numbers right. This is the exercise in your book. X cubed minus 2x squared plus 2x minus 5, yes, over x to the 4 plus 4x squared plus 3. Okay, rational function. Okay, is it proper? Yes, degree 3 out of degree 4. But they didn't factor out the denominator for us, so we have to factor this out. Okay, this x to the 4, 4x squared plus 3, so it should be x squared plus 1 times x squared plus 3. All right. Looks right. And see, what about the top? See if I have any way to take care of the numerator quickly, or another way I try to look for a way to cheat. If not, then we have to do the long way of long division. I'm sorry, long way of fraction decomposition. X cubed minus 2x squared. So x cubed, right? I don't know, so you have to do it normally. X cubed minus 2x squared plus 2x minus 5 over x squared plus 1 times x squared plus 3. Well, if you don't have time to think and you have to decompose a fraction and just follow the rule that we have. We only have 2 factors in the denominator with multiplication 1, so x squared plus 1 in here, and then x squared plus 3 there. Okay, so the top going to be ax plus b, and then cx plus d, and then you have to solve for a, b, c, d. And somehow my simple library should have a shortcut in here to have it. I'm not sure. Let's see. X cubed right here, I can group with 1x right there. 2x squared. I can group with. I don't want to think. So let's do it the formal way. Okay, so the first fraction right here, I have to multiply it back by x squared plus 3. The second fraction, I have to multiply it back by x squared plus 1. So times this by x squared plus 3 times x squared plus 3. Second one, we multiply it back by x squared plus 1, x squared plus 1. All right, and we have the numerator on the left hand side, which is x cubed minus 2x squared plus 2x minus 5 equal to the numerator on the right hand side, a x plus b times x squared plus 3 plus cx plus d times x squared plus 1. Okay, and our job is to solve for a, b, c, d. Okay, I think this is a good example to go through all the set that we learned in pre-calc to solve for a, b, c, d. I'm gonna use the most formal way that we can think of. Okay, so I'm gonna factor out everything on the right hand side. So I'm not gonna cheat, not even a little bit. X cubed minus 2x squared plus 2x minus 5, okay, equal to, on the right hand side I got what? ax cubed plus bx squared plus 3ax, then plus 3b, and I'll do the same for the second factor. I gotta void everything out. So what? Cx cubed. This is my d, okay? This is the letter d. Plus bx squared plus cx, and then plus d. Then I group them together. I'm gonna have what? A plus c x cubed plus b plus d x squared plus 3a plus c x and plus 3b plus d. And it's going to be identical to the polynomial on the left hand side, the cubic. X cubed minus 2x squared plus 2x minus 5. So all the coefficients on the left hand side gonna match up with all the coefficients on the right hand side, and that means a plus c right here gonna be equal to the 1 because the coefficient for the x cubed on the right hand side is a plus c, and it's 1 for the left. That's match up. And then what? B plus d gonna be equal to negative 2 for the x squared term, and similarly 3a plus c gonna be equal to 2 for that x term, and then 3b plus d gonna be equal to negative 5. Not too bad, because I see this is a system of two linear equation. I can use the first and the third equation right here. I can solve for a. Take 3a plus c minus a plus c. 3a plus c equal to 2. A plus c equal to 1. Do a subtraction. So 2a is equal to 1. So a is equal to 1/2. You got a equal to 1/2 already, so you know the c also another 1/2, because 1/2 plus 1/2 is equal to 1. So c is equal to 1/2. And then same idea for equation 2 and equation 4 right here, the second and the fourth equation. I'll take the last one, subtract the second one. 3b plus d equal negative 5. I got b plus d equal to negative 2. I do a subtraction. So d cancel out. 3b minus d is 2b. And negative 5 minus negative 2 is negative 5 plus 2 is negative 3. So b is negative 3 over 2. B is negative 3 over 2 right here. So d gonna be what? Negative 1 over 2. So negative 3 plus negative 1 is negative 4 over 2. Yes. So d is negative 1 over 2. Okay. And you can solve for all A, B, C, D. Not too bad, but really we went through the whole problem using the formal method that we learned in pre-calc. We match up the numerator on the left with the numerator on the right, and then we have to factor everything out, combine the like terms. So we match up the coefficient on the left to the right. We solve A, B, C, D. All right, and believe it or not, the whole big problem that you guys learned a couple of semesters ago in pre-calc now become just the very first part of our integration problem that you learned in Calc 2. Okay, so let's continue this problem. I have to save that part because I need to know A, B, C, D, right? Okay, so integral of, oh boy, I have to copy it again. X cubed minus 2x squared plus 2x minus 5 over x to the 4 plus 4x squared plus 3 plus 3, right? Dx is the same thing as, I can write up here, integral of this one, I factored out already, x squared plus 1 times x squared plus 3, right? So I have what? A is 1/2, so 1/2 of x. B is negative 3/2 over x squared plus 1, and then plus c is 1/2 of x. D is minus 1/2 over x squared plus 3 dx. You guys see what I'm writing there? This is ax plus b over x squared plus 1 plus cx plus d over x squared plus 3, right? And we solve A, B, C, D. This is what I put in there. Okay, so break it out. This is integral. The first one is 1/2 of x over x squared plus 1 dx minus 3/2 of integral 1 over x squared plus 1 dx. I'm just talking about first fraction right here. Say 1/2 x over x squared plus 1. 1/2 x squared plus 1 minus 3/2 x squared plus 1. And you do the same thing for the second fraction. And then plus 1/2 of x over x squared plus 3 integral dx, and then minus 1/2 integral of 1 over x squared plus 3 dx. And you see, this one right here, you do a u sub, u equals to x squared plus 1, we did that. We can take care of this integral. This one right here, tangent inverse. This one right here, another u sub for x squared plus 3. And this one right here is tangent inverse again. Remember the way we modify, divide, multiply the top by root 3. But anyway, this is, I think it's 1 over root 3 tangent inverse. Okay, let's see. All right, so this technique is one. This section show you a technique that one of the techniques you're gonna use a lot of previous techniques that we learned before. So practice, okay? All right, let me move on to the next section. The next section is a summary of everything that we learned. So they say what? Strategy for integration. So whenever you see an integration problem, what should we do? Let's just give you some advices and give you some examples, exercises to work with. Okay, so in general, you learn a lot of techniques already. U sub, you learn in count 1. What else? Integration by parts, right? Trig sub, right? And then what? Integration by part already. Partial fraction, yeah, let me look if I miss anything. I talked about trig sub already, yes. Integration by part, yes. Pretty much. Okay, and you need to know a lot of trig identity as well. Okay, so summarize everything that we learned so far. The first thing is what? You better know some typical one, like a derivative of sine is cosine, derivative of cosine is negative sine, that kind of thing. Integral of 1 over x is ln of x. I don't have to rewrite everything, okay? You guys know that, right? So when you see the problem, what do? You try to simplify it, number 1. Try to simplify it. Simplify. Okay? Means what? You try to make the problem simpler, and you try to bring it back to something that you've seen before. Okay? And then look for substitution. As I claimed, you remember the very first week of the semester, I spent the whole week to give you a review on substitution back in count 1, because I emphasize that substitution is one of the most common techniques you guys use over and over. Try to do use up. It works, great. If not, then try another way. Integration by part. And this is trig sub. Okay, try them. Okay. And in the section of trig sub, I always emphasize is what? Well, this works, but usually when you do trig sub, it's kind of long, and you have to do a lot of calculation. So I try personally, in my opinion, I try to avoid trig sub as much as I can. I do use sub instead, and if it doesn't work, I have to, then I'm gonna go use trig sub. It doesn't mean that I don't know how. I know it very well actually, but try to do less work to get the same result. That would be better. Okay. And of course, if it doesn't work, then what? Find another way. Try again. Oh, we forgot to mention the last one. What? Partial fractions. Okay. Partial fraction. Okay. And practice. That's the key. So I don't see any new stuff in this section that just summarize everything for you. Well, whenever you see a problem, you try to simplify the function inside, see what you have, and try to do trig sub. Try to use up first. And I agree with the textbook at this point. Well, whenever I see a trig integration problem, I would always think of use up first, see if it works. Okay, the integration by parts. You use this technique by parts if usually when you have like 2 different types of function in the same integral. And trig sub, you see the signal right there, what x squared plus 1 or square root of x squared minus 1 or something like that. You see the signals that given. I tell you that you trig sub, and integration of rational functions is using what? Partial fraction. Okay, you use partial fraction, which we just learned today. You break everything out into smaller fraction, and you may have to use some of the techniques that you learned before to take care of the problem. So Let me grab up this section by just randomly choose a couple of examples and put on the board and see how we can tackle a problem. The tricky part of this section is what? They don't have any specific method, and that's how it is. Whenever you do a problem, you try to put everything that you know in one problem. See, we can find a way to solve it. Okay, integral. Let's start with the first one. Cosine x over 1 minus sine x dx. Alright, so what do I see in the problem? I see a fraction. A fraction of what? Cosine over something with sine. I see sine and cosine. That's